We're going to consider this one. A thin rod, 1 meter long, has a mass of 1 kg and 1.5 kg hanging at its ends. Find the point at which the rod can be lifted without the rod tending to rotate. Assume the weight of the rod can be negligible. So the weight of the rod is negligible. Want to find the point where when you get to lift it, it won't be able to rotate. That means the clockwise moments should be equal to the anti-clockwise moments. How do we do that? Well, if this, they told us a thin rod 1 meter long. So if this is 1 meter and this distance is x, then what will be this distance? This will be 1 minus x. So this moment this side should be equal to the moment also this side. So what we are saying is clockwise moment is equal to anti-clockwise moment, and moment is given by force times distance. So F1 d1 should be equal to F2 d2. And F we've been given mass. F is given by mass times gravity. So M1 is 1.5, and then times G, which is 9.8, and then distance 1, that is the same x, and that should be equal to F2, the force, we just know the mass, multiplied by gravity 9.8, and then multiplied by the distance, which is 1 minus x. So let's get to multiply 1.5 multiplied by 9.8. That is going to give us 14.7x, and that would be 9.8 multiplied by 1, that is going to be 9.8 itself, and then 9.8 multiplied by x, that would be 9.8x. I'll take everything that has got x the other side, so that would be 14.7x plus 9.8x is equal to 9.8. 14.7 plus 9.8, that will give us a 24.5x, and that is going to be 9.8. Therefore, to be able to find x, we divide 9.8 by 24.5, and that is going to give us 0.4 meters, which we can convert also to centimeters as 40 centimeters. So that is the distance at which it should be placed. And then there's also this one. State the two conditions of equilibrium. So for equilibrium, the net forces should be balanced. They should be equal to 0. And then the net torques should also be equal to 0. This is just telling us that the net acceleration of a system should be equal to 0. There should be no acceleration. Let's consider this one. The figure below shows a 5 kg block A, which hangs from a string which passes through over a frictionless pulley and is joined to a 12 kg block B, which lies on a frictionless table. Find the acceleration of the two blocks. So the direction of motion is going to be like that. We've even showed more positive. So there's mg here, and then there'll be a tension up like that. So here they've told us what is the table having a friction. Okay, it is a frictionless table, so the only force here is going to be the tension force in the forward direction. That is the force that is going to be pulling this one. So let's start with this mass. The net forces acting on it, that is in the y direction, is equal to mg minus tension going up. The net force, that is mass times acceleration, that will be equal to mg minus tension. The mass, this object, a figure below shows a 5 kg block A, so that is 5 kg multiplied by the acceleration, and that will be equal to mass 5 multiplied by 9.8 minus tension. So 5A is going to be 5 multiplied by 9.8, that is going to be a 49 minus tension. So this will be the first equation. Now we can look at this other one. The net force for that one, since it's moving in the x, is going to be equal to tension. It's only tension that is making it to go in the direction of motion. There's no other force that we can subtract. To be mass times acceleration is going to be equal to tension. The mass, this one has been given as 12 kg times acceleration will be equal to tension. So where there is still, we're going to put 12a there. So that will be 5a is equal to 49 minus 12a. I'll take this time the other side. 12a, it becomes positive 12 plus 5, that will be 17a, that will be equal to 49. Therefore, the acceleration is going to be 49 divided by 17, which is 2.88 meters per second squared. Find the tension in the string. To find the tension, we can just come and use this one, or we can also use this one. So tension is going to be equal to 12 multiplied by the acceleration, which is 2.88. And there the tension in the string is going to be 34.59 newtons. And that is it for that problem also. A block of wood is 20 centimeters long. So this is 20 centimeters long, 15 centimeters wide, and 10 centimeters thick. So it's like that. It's 20 centimeters long, it is 15 centimeters wide, and it is 10 centimeters thick. So we can take the thickness in any way here. So let's say the thickness is here 10 centimeters thick. What is the density of the block? So the first thing we should be able to find is the volume of this block. Volume is given by LBH. So the length, we have got 20 centimeters multiplied by 15 centimeters multiplied by 10 centimeters, and that is going to give us 20 by 15 by 10, which is a 3000 centimeters cubed. Now density is given by mass over volume. We don't know the mass of this object, so that will just be mass divided by. Now let me convert this to the SI unit, or we can leave it like that, 3000 cubic centimeters. And we know mass in this case, then it should be in grams. So this is going to be, we have got a 1 on top there, 1 divided by 1000. This is going to give us 0. Let me write it in standard form as a 3.33 times 10 to the power negative 4. Don't forget m is there. And then the unit is gram per cubic centimeter. So that is it. We can also convert it to kg per cubic meter. Thank you so much for being present. Hope that was helpful.